For decades, the American space program has struggled with a lack of focus. NASA was spread far too thin, attempting to satisfy too many stakeholders while spending billions on projects that frequently missed their deadlines. Now, they are facing a rapidly advancing rival space program. And unlike the 1960s, this modern contest with China isn't about pride. It's about staking the first permanent claims on the lunar surface. Under its previous trajectory, the agency was simply not equipped to win a race defined by speed and permanent habitation. Losing this race means allowing a competitor to dictate the rules of the lunar surface and control access to the most valuable resources. To prevent that, the agency has undergone a radical shift in its core philosophy. Under new leadership from Administrator Jared Isaacman, a new mandate called Ignition has scrapped the old playbook in favor of a ruthless focus on execution. The first casualty of this pivot was the original Artemis 3 moon landing. Recognizing that the jump from a test flight to a lunar landing was too risky, the mission has been reformatted into a dress rehearsal in low Earth orbit, allowing crews to test critical life support and docking systems where they can still be safely reached if something fails. NASA is also forcing a race between private contractors. Companies like SpaceX and Blue Origin are now being put on notice. Only the first to deliver a working lander will actually secure the contract to return Americans to the surface. This aggressive restructuring has cleared the way for a $20 billion, three-phase blueprint to establish a functional, permanent outpost on the moon. By shedding its bureaucratic weight, the agency has transformed into a logistics-focused machine, setting the stage for the first phase of construction. Spanning from 2026 to 2028, Phase 1 focuses on proving reliable access to the lunar surface. The plan calls for an unprecedented launch cadence, sending 25 missions in just 3 years. The immediate obstacle is the lunar night. Because the moon rotates so slowly, any hardware on the surface must survive 2 continuous weeks of total darkness, where temperatures plunge to -200 degrees Celsius, freezing standard electronics solid. To survive the freeze, engineers will deploy radioisotope thermoelectric generators. These devices use the natural heat released by decaying plutonium to keep hardware warm until the sun rises again. With survival hardware in place, a fleet of moonfall drones will arrive. These vehicles use small rocket thrusters to hop across the terrain, mapping out dangerous and hard-to-reach craters. They will be joined by the Viper rover, which is tasked with prospecting the South Pole to confirm the exact locations of water ice and rare earth metals. Surviving the night and locating these resources are the mandatory first steps. This data is required before NASA can send the heavy equipment needed to build a long-term habitation site. Between 2029 and 2032, the objective shifts to infrastructure. NASA will execute 27 launches to deliver the heavy machinery required to build a permanent foundation. This phase involves landing excavation rovers designed to move lunar rock, level the ground for landing pads, and dig trenches to shield power cables and pipelines. To allow crews to work across the surface, NASA is partnering with the Japanese Space Agency and Toyota to deploy a massive pressurized rover. This vehicle functions as a mobile apartment, allowing astronauts to travel for days in a comfortable environment without needing to wear bulky spacesuits. Powering this level of construction requires a massive amount of energy. The initial grid will use solar panels mounted on tall poles to capture maximum sunlight, feeding into large battery systems for storage. This solar power will be supplemented by central nuclear fission reactors. They generate a constant supply of electricity, distributing power to multiple assets simultaneously through a localized grid. By combining both, the base sustains heavy operations even during 2 weeks of total lunar darkness. By the end of Phase 2, the moon will be transformed from a hostile wasteland into a fully powered construction site, ready for its first rotating residents. Phase 3 marks the beginning of continuous habitation. Starting in 2033, rotating crews of 4 people will begin living in connected habitat modules for missions lasting 28 days. To make this outpost sustainable, NASA will begin harvesting the environment. This process, called in situ resource utilization, involves using lunar materials rather than relying on expensive shipments from Earth. This shows the process of refining lunar ice. Once extracted, the ice is chemically split into 2 distinct elements, oxygen and hydrogen. Oxygen supplies the habitat's breathable air, while hydrogen is processed into rocket fuel to carry the crew back home. Simultaneously, 3D printing systems will begin melting lunar dust into a durable cement, allowing for the construction of permanent structures that provide better protection for the crew. Mastering these resources is what finally severs the umbilical cord to Earth, turning a temporary outpost into a self-sustaining base of operations. To keep the public engaged, NASA is ensuring that every drone, rover, and habitat module is equipped with 4K cameras to live stream the entire construction process back to Earth. NASA has admitted that executing this 3-phase plan is nearly impossible, requiring a level of logistical precision the agency hasn't shown in decades. But the stakes of the new space race demand this level of risk. If the United States cannot meet these deadlines, the Chinese program is fully prepared to take the lead in lunar development. Ultimately, NASA is pursuing this plan to serve as a catalyst, providing a real-world example of what can be achieved to motivate a new generation of scientists and engineers. By attempting to build a permanent presence on the Moon, the new NASA is finally leading by example again, inspiring the people who will eventually solve today's impossible challenges.